Here, we'll explore the basics of power and efficiency, starting from the fundamental units that quantify energy and moving towards how energy is dissipated in different systems. Understanding these principles helps us grasp how energy is used and lost, which is crucial for designing more efficient technologies and managing resources better. As we go through the concepts, we'll break down the core ideas step by step, making it easier to see how power and efficiency play a role in everyday devices and larger systems alike. This foundation will prepare us for deeper discussions about energy flow and conservation.
Energy and work are measured using the joule, represented by the symbol J. 1 joule is defined as the amount of work done when a force of 1 Newton moves an object 1 meter. To visualize this, imagine applying a push with a force of 1 Newton on a box, causing it to move exactly 1 meter along a surface. This simple relationship helps us quantify energy transfer and work in a clear, standard way, forming the foundation for understanding power and efficiency in physical systems. Power tells us how quickly work is done or how fast energy is transferred. We can express this with a simple formula. Power equals work divided by time. In other words, it's the amount of work done over a certain period. Alternatively, power can also be described as the change in energy divided by the time it takes for that change to happen. Both formulas show that power measures the rate at which energy moves or work occurs. This helps us understand not just the amount of energy being used or work being performed, but how fast it happens. Power is measured in watts, symbolized as W, which is the standard unit in the International System of Units. 1 watt is defined as the transfer of 1 joule of energy every second. This means when energy is delivered, or work is done, at a rate of 1 joule per second, we say the power output is 1 watt. This unit helps us quantify how quickly energy is used or produced, making it a fundamental concept when discussing power and efficiency. When we transfer the same amount of energy, the time it takes relates directly to the power involved. If the power is high, the energy moves quickly, so it takes a short amount of time. On the other hand, if the power is low, the same energy transfer happens over a longer period. This means higher power means energy is transferred faster, while lower power means it takes more time for the transfer to occur. The boxes represent this visually, showing a shorter duration for high power and a longer duration for low power. Efficiency is a measure of how much of the total input energy is converted into useful output energy. It can never be greater than 1 because some energy is always lost as waste or dissipated in the process. This loss shows up as dissipated energy, which might be heat or other forms of energy that don't contribute to the intended work. Efficiency is usually expressed as a percentage. So, if we have an efficiency of 0.8, it means 80% of the input energy is useful, and the remaining 20% is lost. This helps us understand the real-world limitations and performance of systems when transferring or using energy. Efficiency is calculated as the ratio of useful energy output to the total energy input. This means you divide the energy that actually does the work you want by the total energy supplied to the system. Similarly, when dealing with power, efficiency is the useful power output divided by the total power input. However, it's important to note that the power ratio is only valid when the energy transfer happens continuously over time, ensuring a steady comparison between input and output. This helps us understand how well a machine or system converts input into useful work without wasting too much energy. When energy is lost, it is mainly converted into thermal energy, which then dissipates into the surroundings. This happens because energy transformations are never perfect, and some of the input energy is always spread out as heat that we can't use. That's why efficiency can never reach 100%. There's always some energy lost to the environment, limiting how effectively machines and systems can perform. This loss through dissipation is a fundamental reason why we focus on improving efficiency, but recognize that some energy will inevitably be wasted.